of this lesson in your textbook is anti-differentiation by substitution. The universally used nickname for this lesson is U sub. And that's interesting. I have little marks down at the bottom of the page. Don't know where those came from either. Let's get rid of those. Okay. This is what Mr. Matthews, for those of you that have had this conversation with him, was referring to as the chain rule for integrals. Okay? And I will explain to you why that happens, or why we call it that as we get into it. You will also notice in your textbooks, if you're there, and if you're not, don't worry about it. They have a summary of rules on page 337, but in essence, that's what's on the back of your derivative sheet. So mainly for today, what you're going to need is your derivative sheet, actually the integral side of it. We're going to do a quick definition, and then we're going to do examples. All right? This is new to us, and I'm going to write it up here and tell you what I'm writing, and then I want you to tell me why this is new. The term we are defining here is indefinite integral, and I'm going to ask you now, why is this new and why is this familiar? That's right. And I actually alluded to this earlier in our conversations. What made it definite?
We had a closed interval, wasn't it?
That's right. We were dealing with a closed interval. Okay, so debating about how much of this to write. We'll go ahead and write it. The family of all, and then I want you to tell me what this first phrase refers to that you just did in 7.1. The family of all antiderivatives of a function f of x, and that's where I'm going to pause. In fact, I'm not going to say is. I'm going to change the wording up, and we're going to put a period and call that a sentence. I know it's not officially a sentence by English standards, but it is the definition of an indefinite integral, and we're going to add to that a little bit in terms of some notation and whatnot. What does that relate to in 7.1? Slope fields. Because the slope field is a picture of all of the solutions, right? All your antiderivatives. Okay? So the indefinite integral is all of those. Okay? And the indefinite integral of f with respect to x, which I don't think we need to say, I'm just going to have you write the notation here right below it, is the integral of f of x dx. As Clark pointed out, the distinction between a definite integral and an indefinite integral is the presence or absence of limits of integration. Okay? So we're going to be finding a general antiderivative or integral where we're not going to have a specific value. So your answers will all still have x in them, in essence. It's kind of the way to think about it. You're not going to plug those numbers in and get an actual value. Does that make sense? That's the distinction. Okay? So then we want to go on to say, if capital F, and what have we talked about capital F? That is our official notation for the antiderivative or integral. So if capital F is any function such that, and there's an abbreviation for such that, and that's a little pile of 3 rocks. Looks like a little the vertices of a triangle, basically. Such that f prime of x, I think I'm using the right symbol there. If not, that's what it's going to mean for us. Capital F prime of x. What would capital F prime of x be?
Yeah.
The function. So how would I note that?
Little f of x.
That's right. Equals little f of x, also known as lowercase f of x, because we could make a tiny little capital F, couldn't we? I've got a few people in here who are quite capable. Haney, Richard, Matthew. Varying levels of legibility at points in time. If capital F is any function such that capital F prime of x equals little f of x, or lowercase f of x, then the integral, using the integral symbol, f of x, lowercase f of x dx, equals, now let's switch it back. So what should I write here? You should be able to tell me this. Big or capital f of x plus c, right?
And this is when we have to include C, because like, well, last chat we didn't have to because it was like a close.
Right. Remember how did I show you why the capital C didn't matter on the? Because when we do big F of B minus big F of A, what happened to the C? It got minused away every time, right? So it was irrelevant to the definite interval. So you're correct. This is where you have to include the C. Because when all you know is the thing that you are anti-deriving, that means there's an infinite number of possibilities, and to find a specific case, I would have to have more information. Does that make sense? All right, so then we want to go on to say, and we haven't, I think we've called it this, I don't know that we've written it in our notes, where capital C, and it is a capital C that's used universally to represent this quantity, is an arbitrary constant. Called the constant of integration. That's creative, isn't it? And that's all the notes. We're jumping straight to examples from here. Yeah, we don't have this big theoretical discussion where you're like, what did we just talk about? Or the worst ones to me are the ones where you have this huge theoretical conversation, and then you go do the work, and it's like, did this have, yeah, it's like, why did we have that theoretical conversation? Just so you'll know what you're doing. That's what that is. And I have to, I'm going to tell you a little story, very briefly, that Miss Fox shared with me on...
Miss who?
Fox. I'm trying to think what day it was. I guess it doesn't matter what day it was. I went by to touch base with her on something as I was leaving. I guess it was Friday because we had early. Y'all had early dismissal. I didn't have early dismissal. But in the context of the conversation we were having, she was telling me that when she took Rob to Clemson for the orientation for engineering students, the head of the department that was guiding the tour, having the conversation with him, said something about how you're all cocky and you think you know everything, which presumably would be sort of a prerequisite to signing up for an engineering program. But he said, but you're going to find out how little you know when class starts. And then he started having, I guess there was some sort of a Q&A, or somehow he got the kids that were there for the tour or the orientation to participate and respond to him. And at some point, Rob made some comment, and he said, and he looked down, I guess he looked down at his list, and he said, so you're from Camden, right? And he said, yeah. He was kind of like snotty with him, like, oh, yeah, we'll see. And so, like, I think she said it was like 3 or 4 weeks into the semester. Rob called her all excited one day, and he said, because she said that all the way home she ranted. She was so offended that he had talked smack about Camden. And so she just was like going off the whole way home, like, I cannot believe he said that, da, 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 da. So he calls her like 3 weeks later, and he's all excited. And he said, I had to call you. I just got out of class, and I had to tell you this. He said, remember that day when you were ranting about Dr. whatever his name is, ranting about, like making kind of a derogatory attitude about Camden, whatever? She said, yeah. She said, he asked me to stay after class for a minute today. And when everybody left, he said, I just have to tell you that at orientation, I should not have been that way with you. He said, you have clearly been taught how to do math. So I was like, yes.
Did you teach him?
Yes. And I only taught him AP Cal, and it was one of my first few years I taught it too. So I like to think I'm getting better. Kind of like wine, get better with age. I don't know about all that. But that's okay. I am going to jump past the first set because if your book is open, if you look at these, and if it's not, I'll read a couple to you. Why do you think we probably don't need to do the indefinite integral of t squared minus 1 over t squared? Because you have rules for that, right? Well, they're going to feel like they're misplaced. Those are not U-sub problems. Those are just practicing using your rule sheet problem. Okay? But there's a progression that should happen. Remember in derivative land, I taught you a progression? You start off taking a derivative. The first thing you try is to look for a rule. If you don't have a rule, you look for some other way to write the thing, right? Or manipulate it into a format that you can use, that sort of thing. And if you don't have a rule, then we also learn things like the chain rule. How did we know we used the chain rule? What was the tip-off?
Well, yeah, it was like a function and a function.
Yes, and it's a what? I was going to say, somebody's going to say, it's the composite function. It has a function inside a function. So where I see an x, I see something like a 3x squared, right? That makes it a composite. You're going to have the same sort of tip-off here. But we will go ahead and do number 8, just because these aren't hard. They're just kind of weird. All right? So on number 8, your directions say use differentiation to verify the antiderivative formula. Okay? And the formula you were given on number 8 is the integral of cosecant u, cotangent u, equals negative cosecant u plus c. Now, honestly, I'm not sure I've ever actually used this as one of my warm-up examples to what U sub is, but we'll see if this helps you. When you look at the left side, something in your brain should be seeing something that feels like there's a missing piece. What feels like it's missing? Dx. All right, well now look at your integral sheet. And this is, and I'm not just disregarding what I just said. I'm just telling you we're gonna that's where we're about to head. So look at your integral sheet and slide your eyes down towards the trig section and see if we have a rule for cosecant u, cotangent u.
Yeah.
We do? What is that rule?
Cosecant u, cotangent u, du is equal to negative cosecant u plus c.
Yeah. So it's the same. But I'm trying to figure out what it is they want us to do here. Well, let's take the derivative and see. If I take the derivative of the left, what would I get? Taking the derivative is getting rid of the integral because it is the antiderivative. Does that make sense? They're inverse operations. All right? So if I do that, I'm losing that integral sign, right? So I've taken the derivative of both sides. So maybe I will jot that in a contrasting color here, that we took the derivative with respect to x of the left, and we took the derivative with respect to x of the right. That's what we're about to do. Okay? Well, when we do that, now we have to flip back to the front side of the sheet because we're taking the derivative of negative cosecant u. What is the derivative of, well, first of all, what do I do with that negative? Pull it out. All right, so then I'm really looking for the derivative of cosecant u. And what would that be?
Negative cosecant.
So it's, okay, wait, let me do this. I said I was going to keep that negative, and I'm going to do this to be emphatic. It's negative because that was the negative that came with it, right? So that was the constant I pulled out, but then the derivative itself is negative. How should I have known that before I looked at my derivative sheet? All the...
Cos are negative.
That's right. All the co-functions' derivatives are all negative, okay? So this is negative cosecant u, cotangent u, which verifies our formula. And the reason I thought it might be good to go ahead and do that kind of problem is those should be stupid easy in the sense that I just showed you. But for a lot of students, they're not because you're like, what am I even doing, okay? So
you just have to make them equal?
and actually, I did say something was missing, and then I didn't get you to tell me what was missing over here on the left. Du. It's a typo in the book. I left it off just because, and I was wondering if they did it on others, and I skimmed down. I don't think they did that on any of the odds. So you won't run into that. That should have been a du there. And my scattered brain trying to do all this processing at once was too much. Okay, so that's pretty much how you're going to do that set. Simple enough? You're simply going to take the derivative of each side and take care of that. So there should have been a du there, so go back and squeeze that in right there if you can. All right, on to the next set. I think I'm going to skip on down to, I guess I'll do number 18. I don't really like this set of problems because I feel like if you've actually been taught the lesson, you don't need these. But I'm going to do them just so you can see this is to kind of get you thinking in the right direction. And they give you your U, which I don't really like. But I'm going to go with the flow this morning. I'm too tired not to. All right, in this set it says use the indicated substitution to evaluate the integral. Confirm your answer by differentiation. All right, well, if I want to rewrite this as the integral, because substitution means that I'm replacing something that it is equivalent to with whatever it is. Does that make sense? Okay, so what's the only equivalency we've been... Oh, well, Lord, don't let me do one of yours.
Oh.
Sorry about that.
Yeah, I was like, okay, I guess I'll switch this.
Losers. Okay, x cosine x. Sorry, and I told you didn't have to have your book open, so thanks, Clark. The rest of you are like, yeah, thanks, Clark.
Well, no, I didn't know if you meant to do that or not, so I was going with it.
I don't know what I mean to do this morning. All right, you... Yeah, yesterday was a very long... Okay, now it's not writing in this mode. Let me try.
It's right over there in the corner.
Why is it right? I think that's just where the heel of my hand was propping, trying to figure out why it wasn't writing. All right, let's try this again. U equals 2x squared. All right, sorry about that, guys.
Maybe that's what was wrong with it earlier.
Yeah, because it marked at the bottom.
Okay, and it's probably just me. Well, and I had switched. That's too much detail. You don't care. And if you do, I'll show you later. I'm not a detail person, and when people break off into the details of something, like, we really don't care. So I don't know why I was about to do that to y'all. Okay, so back to this. So we are to use the indicated substitution. And again, substitution is only allowed in math when the thing you are taking out and replacing is equal, right? So what was there is equal to what I'm replacing it with. Does that make sense? Mm-hmm. Okay, real simple idea. What is the only equivalency I know in this problem?
The U equals.
Thank you. There's an equal. Thank you, Clark. There's an equal sign in one spot in the problem, and it is U equals 2x squared, right? Y'all are worse off than I am, apparently, and that's not good news, okay? Okay, so we're going to rewrite this x thing and replace the x's with the u's, but I have to be able to do that the right way. So bear with me. All right, so let's do the easy part first. So we're going to keep the integral. Actually, get a pen instead of an eraser to write with. And I'm going to leave a space to deal with that x. In fact, let's just put some parentheses there, and we'll come back to that. All right? And u is 2x squared, right? So that means inside my cosine, I can have just u now, right?
Oh, and you solve it for x.
Okay. Well, then, if I've got this integral, and this is where I was getting ahead of myself on the last problem. So what has to be there in order to replace the dx? A du, right? So I have to have a du, so I'm going to go ahead and tack that on there, even though technically that's not a direct replacement for dx. And you'll see why. Because if u equals 2x squared, what does du equal? I take the derivative of u. What is the derivative of u?
4.
It is, so this is du dx I'm really finding. Let me be more emphatic so you'll understand what's about to happen here, okay? So it would be 2 times 2x, aka 4x, right? So that means that du equals 4x dx. Right? Well, I've already written the du there, and so my du has to represent 4x dx. And so if I put the 4x here, what did I bring in that wasn't there? And I'm going to give you a minute to think about that. Because to me, these problems are kind of harder in a way. They should be easier, but they're actually harder in a way because of what you have to do To me, you'll understand these better after I do some the way I'm going to show you to think about them.
Can you repeat the question again?
All right. Well, we just did substitution, right? Well, the 2x squared that I took out and replaced with u is obvious, right? Well, I can't just arbitrarily drop the dx dx, can I? I had x dx there, right? So what's in my du that wasn't in the original problem? A 4. How can I make up for the fact that I just multiplied something by 4,
Okay.
1/4.
put a 1/4 out front?
Wait, I don't really understand. So why did we stick the 4x?
Oh, I'm sorry. No. My bad. Let me rephrase that. Okay. I actually shouldn't do that. And I'm having to think. This is artificial to me, so it's making it all weird and clunky. All right. So I had an x dx, right? But if I write the du, that du has in it 4x dx. Does that make sense? So I actually don't need anything written where I had the 4x written because that's in the du. So I brought in a 4 that wasn't there, so I put a 1/4 out front.
Okay.
Does that make sense?
So
What do you do about the x that was there though?
Well, it's in the du.
Okay, and that's what
See?
we put for the
that
X
makes
now.
sense because then you
See what I'm
have
saying?
dx
du has all the 4x dx already in it, right? Well, there was an x and a dx that was already there, so I didn't bring that in. It was there. You with me?
Yes.
What did I add to the problem by switching it over to u? You with me now? So how did I fix that? I put a 1/4 out front. Okay, does that make sense? Okay. And then it wants us to evaluate. So when we evaluate, why is, now if you understand that, and like I said, these are just kind of awkward to me, this set of problems, and I'm probably presenting them in an awkward way because of that. When we get to the legit, straight up use of problems, it'll go better, okay? Why would you rather, and I'm open to any kind of answer to this, why would you rather take do the integral 1/4 the integral of cosine u du than you would the integral of x cosine 2x squared dx?
Because we have a rule.
Because we have a rule for that. That's the whole point, right? So we're going to take things we don't have a rule for and write them in a form that we do have a rule for and work backwards from there. So what would my integral be? Well, first of all, we pull off constants, right? That's a rule we've already talked about, just like in derivative land. And then we say to ourselves, what is the integral of cosine u? In other words, what do I take the derivative of and get cosine? So this would be sine u plus c. And there's one more step. This sort of a universal good manners math rule. What do you think? Mhm. Put your u back in.
Is this C here capital?
Yes. 1/4 sine of 2x squared
Is the 1/4
plus c.
going to C2?
That is a very astute and thinking ahead kind of question. It doesn't matter. Why doesn't it matter? Because what is c? It's some number, right? So how I set it up will determine what my c is, right?
Oh, so it's okay if you do
Yeah.
or do not?
Yeah.
Okay.
Good job, guys. All right, I think we're ready for a real one. And I think you're actually going to like the real one better because maybe I'm going to make you like them better because I like them better, so I'll do a better job of it. How about that? All right, so here we go. Now, and then I'm going to ask you questions about the one we just did in the context of this one as well, if I feel the need based on how you respond to this one. All right, number 26, we have the integral. I swear there's an integral here. Am I making marks again? I know I made that. I knew I made that mark, but that's what it is. I've turned the orientation of my screen so that I can write on it better, and it's messing me up. Okay, so the integral, and I'm writing it with an eraser now, so that's definitely not going to work, of secant squared of x plus 2 dx. Okay. Now this is what I want you to learn, and to me this is much less artificial, and this is what you need to walk away from this lesson with, okay? Because when you're taking the AP exam, it's not going to say use substitution to do da-da-da-da-da. It's going to hand you an integral and say, what's the answer? I mean, obviously not in those terms, but you're going to be expected to know how to approach each problem. So you have to have a strategy that starts forming today. Because before today, how did you take integrals?
With my sheet.
You used your sheet because we've done nothing but integrals for which you had rules, right? And there were some, it was hard to see that you had the rule. You had to kind of play with it a little bit, maybe, but not much. But now we're going to see how to take the integral of a thing for which we don't have the rule. And our first set of things that we're going to do that with are these kinds of functions that we've dealt with in this one and the previous problem, and that is composite functions, as Mr. Matthews has previously referred to this as the chain rule for integrals. And it is, and the way I prefer to think of it is this is u sub, and I think if you just know it as the chain rule for integrals, you'll forget what understanding the name of it does to help you think about it. All right, so this is how it works. You look at this function, you say, well, I don't have a rule for this. And then the very first question that should start forming in your head today is this a u sub problem? It's a u sub problem. If I had to take the derivative, it would have been a chain rule. You with me? Because it's a composite. Okay, if I have a function inside a function, whichever version of that makes the most sense to you should be the one you adopt. So if I have the secant squared of the quantity x plus 2, this is definitely a composite function, right? Because where I'd like to see an x, I see an x plus 2. Okay? So here's the great news. Your u that you're going to use is whatever's inside. Okay? So your first step is to decide what that is and record it over to the side, which they kind of did that for you in the first ones, which is sort of awkward and artificial. All right? Well, I've also got to replace, in addition to having to replace the x plus 2, I've got to be able to also replace the dx. And that's going to remind you that we're going to find our du dx. And I would like to see you writing this step full out, even though your brain will start taking shortcuts with it, because it's important that you understand we are truly substituting each chunk. Okay? All right? And I'll show you that as we go in just a second. So what is the derivative of u with respect to x? 1. Right? So this is 1. So then that implies that my du, that differential, is just dx. So in this particular case, my du equals my dx. Why? Because the derivative of the inside function was 1. That only happens when that's true, and that's not going to happen very often. So then now we're going to come back to our original function in terms of x and rewrite it in terms of u. Well, the first part's easy. It's going to be the secant squared of u. Right? But then the second part's still easy on this one because dx is equal to du.
When you put du.
I'm sorry, that was supposed to be a u. Okay? So now we have a rule for that, don't we? What do I take the integral of and get secant squared?
Tan u plus c.
Tan u plus c, but that's not my final answer. I'm going to go back and be a polite math student and write that as tangent of x plus 2 plus c, and we're done.
Is that like the u subsection on here?
Yes.
That's okay.
Yes. The u subsection that I added to your reference sheet is today's lesson. Okay? So it's got steps on it as well, which is the other reason I didn't write steps out. Okay. Shall we do another? Fabulous. Let's do number 28.
If you have like a
I'm listening.
triple composite, how would you do this?
I don't think you're gonna have one of those.
Okay.
If I'm wrong, we'll cross that bridge when we come to it.
Do you always sub u, or does it really matter? Or do you just use,
I don't know what other.
like, do you always, I don't know.
Do you always use the letter U? Yes. Kind of in the name, Morgan. U sub. And it will also help you understand why the back of your sheet has all U's on it, and the front of your sheet, I think I put X's maybe. Did I put U's on the front?
X's.
Yeah, that's what I thought. Okay. So, here we go. Do we have a rule for this?
No,
Why not?
because it's a composite.
Because where I would like to see X or theta, I see theta plus pi halves. So over here to the side, we're going to go and write u equals theta plus pi halves. But I've got to also be able to replace d theta in terms of du, so I have to take the derivative of u with respect to theta. And it's just 1, so that means that my du actually equals my d theta. Don't get used to this. This is baby steps. This is training wheels. I'm about to kick them off here in just a second, all right? So then if I rewrite this thing that came to me with thetas in it in terms of u's, what am I going to have? Secant u, tan u, du. And I will tell you there is a growth process that happens in your sophistication and understanding of calculus that you will know you have reached a new level the day that you can do a u sub in your head. And I have one of my former students who came back for help. He was in college and came back for help because he had a professor that was confusing him on things he already understood. And we sat down for about 20 minutes. And he looked at one and he said, oh my God, I just did that one in my head. It was like, ooh, that felt good. Yes. So when you write it this way, why is it so much better? Well, to get you ready for that moment of, oh my God, I just did it in my head, how could you sort of forecast that on... Because you got the secant times the tangent, right? So that's what you're going to learn to see that you don't really see yet. Does that make sense? Okay. So what is my rule? What does my rule tell me about the integral of secant u tan u? It is secant u plus c, which I'm not going to leave that way. I'm going to go back and put my theta in it, which is the secant of theta plus pi halves plus c. Make sense? Let's see if I can't pick out one that's a little more interesting. Yes. Here we go. Didn't have to go far. Number 30. We have the integral of 3 times the sine of x, the quantity raised to the negative 2 power, dx. What's my u? Sine x is my u. So u equals sine x, and I'm going to need to replace dx with du, so I'm going to take the derivative of my u expression with respect to x, and what is the derivative of sine x? Cosine x, which makes my du the equivalent of cosine x dx. What should I do about that 3?
Pull it out.
Pull it out. Then I have the integral of...
Would you want to go ahead and put 1 over cosine x?
No, you wouldn't want to do that.
Oh.
Why are we... what are you going... You've lost your mind.
I think so.
Because what do I do? Once I know what my u and my du are...
Plug in.
So this is just u to the negative 2 du.
But what about the cosine x and your d?
We don't have to count.
It's in there. My du has that in it, right? Because what does du equal? Cosine x dx.
Do we have to take out the cosine somehow?
Yeah, like I'm thinking about for number 18, there was a 4 in it, but we didn't have it in our regular thing, so we put a 1-4. Do you not have to do something like that?
No.
Oh.
Because that's the derivative of the inside.
Yes.
And so you keep the du because that's the derivative of the inside.
Yes.
Like you would keep, it's just like that's your chain part. The du is your chain part that you multiply by.
Okay. So why is that different from number 18? Why did we have to do 1/4 for that one?
Because it was a constant.
Oh. Okay. Makes sense.
Oh, yeah.
Yes?
I see.
Okay. So what is this integral?
U to the negative 1 over negative 1.
It's 3 times u to the negative 1 over negative 1 plus c. So this is
-3.
-3
I mean,
times sine x to the -1 plus c. And what's that? Because you wouldn't leave sine to the -1, would you? Because that's 1 over sine.
Which would be
no,
Cosecant x plus c. Does that make sense? That was not where I was going. Alright, y'all just seem out of it and tired and did y'all try to do too much with your extra 2 hours yesterday?
yes.
Sleeping was a good choice. Alright, here's number 34. We have the integral of the 7th power of tangent of x halves times the 2nd power of secant x halves.
So your u would be x over 2.
Or would it?
Or would it?
I'm not thinking it would.
It would be
But
or 1/2.
wouldn't you want to do it like it's going to be a trig probably, because when your outsides be like u to the 7th and u to the 2nd?
Or we,
That's what my
You can't
cousin-
have, okay, why can't I have u to the 7th and u to the 2nd?
those are, you has to be
Because those are
equal.
two
So
different
what'd you do?
Yeah, those are two different things. U has to be equal to one thing.
What
You
did
want
you
to
do? U to
take
the
out.
2nd? I do. You got tan squared.
because like that's not a, like even if you do it, that wouldn't be a rule.
Then what would you do with that versus?
Would you like take out 10?
I can't quite tell if y'all are saying this, but try rewriting it this way. Put the tan x, and I thought Madison's question might get you thinking in this direction. The 7 is actually outside the whole thing, right? And then I have times secant squared x over 2 dx. See if that helps you. Now, I intentionally, why would I not mind the secant squared staying secant squared? Because that looks familiar to me. Does that look familiar to you? And in fact, what is the relationship between tangent and secant squared? I want to look at your
Derivative.
Yeah, we have a derivative relationship there, right? Which is what I need. Because if I've rewritten the first piece so that this is the 7th power of the tangent of x halves, which is actually the way I read it, also trying to nudge you a little bit. What's inside now? You're not like, tan. So u equals the tangent of x halves, period, right? So then my du dx is going to be what? Now this is a composite that I'm taking the derivative of. So this is sort of your 3-layer rule, Morgan.
Secant squared.
So it's going to be secant squared x over 2
Times 1/2.
times 1/2. Now notice when I did this, that secant squared seemed like it was bothering. As a new student, it was probably bothering you. But when that happens, try to look at the other one, the other factor, and see if you can work with it as your u term and see if you get the right derivative that's there. Do you see how my derivative is now shown up? Okay.
So this would be when you pull out the 1/2, or you do it times 2,
Yes. Why?
because there's a constant.
Because there's a constant here. So my du is equal to 1/2 secant squared x over 2 dx. Right?
Right.
So now I have the direct substitution. And something about that last one's bothering me, so I'm going to come back to it, okay? All right, so, but I don't know that I might just do it in writing and give it to you tomorrow or something. Depends on, because we're kind of running out of time. All right, so then if I rewrite this in terms of u, tell me what I have.
U to the 7th.
The integral of u to the 7th
Secant.
du, but what's missing?
The 2.
Yeah, I got to put a 2 out front to make up for the fact that I did what? I brought in a 1/2. Does that make sense? Okay. So then this would be 2 times what?
2 times u to the 8th over 8.
U to the 8th over 8. Do y'all agree with her?
Yes.
All right. You know, I just don't want this to be a conversation between me and Morgan, and with the occasional contribution by Zach or one of the others. Okay. So then this is, and do this now. And this is something else I'm still seeing on the last test I graded, which alarmed me. 2 over 8 is 1/4. So don't write 2 over 8 on every step. That makes you look like you don't know what's going on. So this is really u to the 8th over 4, right? Plus c. So that makes my final answer, what's u? Tan x over 2 over 4 plus c. Oh wait, I'm sorry, 10 to the 8th. We left our 8th off, didn't we? I was looking at the next problem and realized I didn't write that 8.
So why wouldn't we do anything with the secant squared?
Because it's already there. And that's why I said I screwed up on that last one. I got to go back and figure out where I screwed up, but I don't want to double back. I'm going to make it up to you on this next one. We're going to figure it out on this next one. I just wasn't thinking right on that last one. Okay, so 36, we have the integral of dx over sine squared 3x How should we rewrite it?
Sine 3x to the negative 2.
Okay, sine 3x to the negative 2. I can live with that. All right, but we're going to have and I've misled you, so I know I've already sort of planted a bad seed, and I'm trying to help y'all learn how to think about these without me doing it for you. So looking at the last one we just did, everything we created in the DU was in the problem, right? Mm-hmm. Okay, and it should be except a constant. And I should have addressed that a minute ago, but we'll address it here. So now look at this one and see if you can think about this one. If I think about it from the perspective that you said, what would my u be?
Sine 3x.
And what's the derivative?
Cosine 3x.
So it'd be 3 cosine 3x. And we don't have the cosine 3x. You can't just ignore an extra thing you bring in. You have to adjust for it. So if we're in trig land, what could we do about that? And I'm not going to tell you because y'all keep showing up weaknesses in your trig, and that's not good. Some of you are like, I still have to learn my trig. Wow, what are you waiting for? That's what I want to know. What are our options? Maybe you should get out your unit circle.
Is it whatever sine squared? Did you change it to
Maybe get out your unit circle. What do we do when, I'm trying to think where we did this in derivatives. When you don't know how to take the derivative of what you're looking at and it's in terms of trig, what is an option you have that you don't have anywhere else? Use an identity. Okay, let me rewrite it. I tell you what, let me rewrite it this way. Instead of going with, which I kind of like your instinct, but at the same time, it won't work for you here. And that's why I didn't really make a big deal about the fact that it's been suggested that we rewrite this with the exponent outside, because I think that would actually make this problem worse. If I write that as 1 over sine squared 3x dx, and in fact, I think what we're going to do is back up and redo number 30 for the same reason, so that we can fix the error I made in that problem by trying to push you towards some different problems. All right, so look at your identities. And clearly, if we're going to use an identity here, it's going to be a reciprocal identity. This is equal to the integral of cosecant squared
3x.
3x dx. Right? Why? Because I can write 1 over the sine of 3x, the quantity squared, and it's the same thing, right? So that means I can rewrite 1 over sine 3x as cosecant 3x. Are y'all with me? Which is then squared, and that's what that notation means. Are y'all with me? Okay. So now this is yet another opportunity to get some cleaning up done on your trig understanding. So now is the time to pull the square out. And you don't have to write this step if you don't need it. In a perfect world, you wouldn't need it, but you might need to, and you need to write whatever you need to write to get your thinking straight. And some of you who haven't mastered trig yet, it's because you've refused to write things I've been telling you all along you needed to write. So figure it out now, because we're winding down on the material, and we're going to start prepping for that AP exam. So what's my U now?
Cosecant.
U is cosecant 3x. And I know I'm going to need my du dx, which is... Well, first of all, here's a thing you might be sophisticated enough to latch onto. And for those of you that don't like writing steps, you should appreciate this. I know that if I'm going to take the derivative of this right side as a chain rule, I'm going to have to take the derivative of the inside, which is going to pull a 3 out front at the end. I may as well do that now, right? So I've dealt with the derivative of the inside before I even look at the cosecant, right? Okay, and what is the derivative of cosecant?
Negative
Well, I'm going to go ahead and put the negative on my 3. Y'all go with that? And it's what? Cosecant x, cotangent x.
Yeah, it wouldn't be 3x.
Yeah, it is. I'm sorry. Those are 3 x's. I was just hearing the x's. I've demonstrated I'm not all here this morning. Cosecant 3x, cotangent 3x. Okay? So then my du is all that dx, right? Now this is where, and this is the kind of problem I was trying to get to, because there's something in your brain that says we still don't have everything we need. Anybody having that feeling? Because if I just replace that with u, then my du is going to have what in it?
Could you
Okay, what can we do about this?
make cotangent? That would be cosine over sine. So could you make it another cosecant times?
Well, I think the last thing you said is what I was wanting to hear, but not the first part. And I don't know that everybody was listening to what you said anyway, but look at this. What if instead of thinking of that as u squared, I think of this as the integral of cosecant 3x times cosecant 3x dx. Is that helpful?
We made up for 1.
It made up for 1, but it didn't make up for the cotangent 3x, did it?
Could you not split it apart, the cotangent? But then I don't know what you
I was going to say, what's that? But okay, and I don't mind y'all thinking out loud, but think about what you would do with that to account for that.
Would you just kind of like, you know how you would multiply by like a 1/3 out or negative?
You can't do that with functions. You can only do that with constants.
Okay.
So what are we not thinking about?
Cosecant?
Wait a minute. I think y'all have the wrong...
Yeah, u would be 3x because cosecant squared is a rule in the sheet.
Please say that again, Dawson.
U would be 3x because cosecant squared is one of the rules on the sheet.
I was like, this is not working.
Okay, so clearly... Thank you, Dalton. He doesn't make contributions often, but when he does, they're quite pointed. And when y'all are as off as you are this morning, it doesn't help the fact that I'm off having to try to adapt to this little format I haven't used in a while and exhausted on top of it. And y'all should be on point with, don't we know how to take that? Do now? Y'all have a sheet in front of you. So we can back up to there, right?
Right.
Okay. So let's come back and ignore all that other. And I wouldn't erase it. I would exit out because here's what's going to happen. Y'all are going to, if you think we're going to do that as a class and it's not going to happen to you, I don't know what you're smoking. Because it's going to happen to you that you're going to do a U sub when it's not a U sub. You know what I mean? Like you're picking the wrong U. Picking U is everything in this problem. And in a lot of problems. So what's my DU? 3dx. Why do I like that better? Because that's all there, right? So then this is equal to the, what do I put in front? 1/3. The integral of U du. Yes?
Yep.
So that is equal to 1/3.
I have a question. Why don't you just plug in U for 3?
I'm sorry, I lied. See, I'm just getting so addled I don't even know what to do with myself. Try that again. This is equal to the cosecant. God almighty, now I'm writing with an eraser. The struggle is real. All right, here we go. Cosecant squared U du, that makes more sense, equals?
Negative U tangent.
So if it's negative, I'm going to go ahead and put the negative in front of my 1/3. Y'all cool with that? Negative.
Tangent U plus C.
Now, I'm not telling you because that's the whole point. Y'all should be interacting with that sheet so that you can see how you're going to do this when I'm not standing over you.
You can just put 3x in for the U.
Cotangent what?
U
And if you don't want to write the U step, we'll go ahead and put the 3x
plus C.
plus C. And we're done. So now let's go back and see if we can't fix whatever number that was. What number was that one? 30?
30.
Yeah, I botched that one. I'll own that one. But I will say that there are extenuating factors, one of them being y'all. Because y'all are not having your best morning either. I need y'all to have your best morning when I'm not having mine. All right, so look at how we did it before. And it goes back to Morgan's question, well, we can't just throw out that cosine x. And something in my brain was like, yes, we can. No, we can't. So
Did you do the
what was our strategy then? What did we start with as our U? Okay, well, I want to come back and do this one in the context of what we just did for what I hope is obvious reasons. I'm going to pull the 3 out front, and I'm going to rewrite sine x, the quantity raised to the negative 2 power, as 1 over
Okay. Now.
sine squared x dx.
then you
So
change
that's
the
cosec.
And I forgot that they throw some in the middle of this that aren't really U sub problems to see if you're awake. And I clearly wasn't. Okay, so we have the integral of cosecant squared x dx. Do we need a U sub for that?
No.
No, we don't. That's equal to negative 3, or not negative 3. 3. What is the antiderivative of cosecant squared?
Negative cotangent.
So I put my negative in front of my 3 now, right? Cotangent x plus c. Didn't even have to use up that one. I forgot they threw those in here. My brain was full out U sub mode. Should have done a better job picking examples. Simple enough? So the moral of that story is don't use sub just because you can, and you also see what happens when you use it when it doesn't work. It gets nasty. All right, let's try one more to end on a positive note here. Let's jump to, I'm torn. I guess I'll do 38. I wanted to do 40, but I think 38 might be a little scarier looking for y'all, so I'll do it. We have 6 cosine t over the quantity 2 plus sine t squared dt. Isn't that ugly? I mean, in y'all's eyes, anyway. All right. Well, this one is definitely a U-sub problem. And you'll know it's 100% a U-sub problem when you have something that looks like this that doesn't even remotely look like any of the rules on your sheet, right? Okay. So the little moment we had where Dalton was like, wait a minute, shouldn't we have looked to see if we had a rule for that before we started U-subbing? Yeah, you have to have that process in your mind the whole time, and that's how you'll keep from making those errors, all right? So in this case, being said that this is definitely a U-sub problem, what's my U? And I don't know why I wrote equals there, because we're going to move over here and do our U. What's inside?
2 plus sine t.
And let me just give you a little tip. When you're doing U-sub and you have a rational expression, the U, if it's not the whole denominator, it's in the denominator. That's just a general rule. And you'll see why when we do this example. And I'm kind of rushing past a couple points so we don't run out of time. So we have 2 plus sine t as our U, making our du
Cosine t.
cosine t du. Right?
We want to be dt.
Yeah, dt, I'm sorry. Det, because we're in t's now, right? Okay, so the dt's there, right? And I don't have to adjust for anything. Why not? Because that cosine's already there. What about the 6? What do I do with that?
Pull it out.
Pull it out because it's a constant they gave me, right? So I put it out front. And so do y'all see that? And I'm going to circle it in a different color to emphasize what I'm doing here. Do you see that in the original problem? The cosine dt is our du. So that when we write our du on top now over, what's on the bottom? U squared. So this is equal to 6 times the integral of u to the negative 2 du. And I wrote it both ways because you got to get comfortable with writing it both ways as well and translating it when you see it both ways. All right, so then if I integrate that, that's stupid simple, isn't it? So it's 6 times u to the negative 1 over negative 1 plus c. And you can write it that way and then switch right into cleaning that up and plugging in your t expression at the same time. So now I've got negative 6, and what's my u?
2 plus sine t.
All right, so I'm going to go ahead, since they wrote it as a rational function, I'm going to put that negative 6 over 2 plus sine t plus c. Better? Get the idea? All right, we will definitely have tomorrow and probably Friday to work on this in class. Okay? I need to get some rest or something.